healthcare system in France. And another point that I wanted to highlight before my presentation is that European project. You can see more information on our website. It is dedicated to a new transition, which is a transition towards 5.0 organizations. And so it can be interesting for you as future researchers also. So we work on different, you see, field of application, industry, health, and agri-technology. And the link with what we do here is that what we want to do is to, as mentioned in the title here, to train decision makers in 5.0 organizations. So train managers of 5.0 organizations. And how to train them? Well, to train them, we use the OMILAB capabilities and the OMILAB innovation laboratories for two purposes. One is what we call the catalyzer. That means to train students on 5.0 innovations. And the second is what we call the booster. We develop also collaborative innovation activities and research, applied research activities oriented on the transition towards 5.0. And for all that, we use some of the skills, competencies, and resources that you learn here at NEMO Summer School. And just to give you a flavor of what we call 5.0 organization, I have a small video, just 30 seconds, I think.
Technology. Technological innovations shape our current society. We could use technology to improve mass production effectiveness. However, preserving our environment is becoming increasingly important. Thus, we need to shape our society so that we can use the technologies in a way it focuses on the environment, on the people, and resilient systems. Therefore, our society is on the verge of a change from the current 4.0 industry that focuses on smart manufacturing, digital transformation, and flexibility in production and manufacturing, towards a new type of society called Society 5.0, a super smart society that sees people and machines working together in a digital innovation environment. With the creation of Society 5.0 comes also the creation of 5.0 organizations. It is an organization that focuses on the use of human skills combined with the technological potential, encompassing three approaches: resilient, green, and human-centric. But there's a lack of humans possessing the skills needed for Organization 5.0. Thus, universities and vocational training organizations need to be able to educate the future generations and give them the skills, knowledge, and competences they need. That is where CoDEMO, the EU project, comes in, building a network of European-wide partners in Italy, Germany, France, Spain, Romania, and Poland, helping to educate students and professionals to acquire the needed skills for the 5.0 organization.
Yes, good. So that was the minute of publicity. Sorry for that. But in case you are interested in the future, well, come to next year NEMO Innovation Camp. So. And now let's switch to the content of my lecture for today on product service systems and what we call also smart product service systems. So I will follow that agenda because you see a lot of different lectures and input during NEMO. So first we take a few minutes to understand a bit what I am talking about on product service systems. And then yes, analyze a bit or emphasize some challenges for the industrial companies to go towards such economic models and industrial models. And then I will focus on a specific question, which is the design question. When we need to design that type of complex systems, which kind of methodology to design them, and then which kind of support we can bring through a conceptual modeling method that are the focus of our summer school. So product service system, what is it about? Perhaps some of you are working on that topic. I don't know if in your master's or PhD thesis. No, nobody working on product service systems? Okay. So some key elements you have seen with Dimitris yesterday, notion of product design and lifecycle product design. So, well, in a product service system, of course, we have that product part, a product to, well, ensure some functionalities and a product which can be purchased by a client, a customer. You saw also with Professor Hara from Japan the notion of service. So service is something a bit more intangible. It's some added value that you deliver to an actor, your client, customer, and that added value will result at the end in some change of status for the receiver of your service. And then we have the notion of system also. What is a systems? Well, it is something linked to complexity, to interaction between a lot of components, and also something which is generally the notion of the. And so we understand what is product service systems. And I put that definition of our colleague, Professor Macallon from Denmark. And that definition, so we can take the time to read it. Product and service elements and delivering the value through novel channels. And so that definition put the focus on something additional, which is the notion of value. That means when we work on product service systems, we first work on a value proposition, how to bring value on the market, how to bring value to a set of customers, and how to deliver this value also, through delivering the value through novel channels, novel ways to deliver the value. So the notion of value system is very central to understand product service systems. And so to understand also some additional elements, well, that graph shows you that when we talk about product service systems, we talk about the mix between products and services. And so we have different balances potentially between more product-oriented systems and more service-oriented systems. And so one of the very basic typology, you can see it's quite old today, shows you that there is a first categorization, classification of product service systems with the three main types. Product-oriented, when we have quite a low level of services. In fact, in that first classification of product service systems, we maintain an old economic model, which is to sell the product, but we add during the life cycle of the product a certain amount of service, and we contractualize and sell the services in addition to the product. So this is a product-oriented PSS. But then for the two other categories, we change the economic model. In the use-oriented model, what we sell is no more the product. What we sell is the usage, the utilization of the product. So that means that we make available the product in a period of time, and we sell to the customer depending on that period of utilization of the system. And we have different subcategories of that type of product service system. So we sell the usage, the utilization of the system. And here, in the last class, we sell not the utilization, but you sell the performance of the system. So we have, as a provider of the solution on the market, even a more higher level of engagement, of guarantee, because we guarantee the results, the performance of the system that we put on the market. So different types of product service systems that you can find in the economy today. So that question of product service systems is the question of servitization. So how industrial companies oriented on products can, well, be transformed towards more service activities. So this is a process of transformation that we call servitization. But then, at the same period of time, in the last 15 years, the strategy of digitalization, of course, has been a lot developed in industrial companies, and the convergence between the two of them makes what we call smart product service systems. So in smart product service system, not only we put the focus on adding services in the product lifecycle, but we try to use the full potential of data and digitalization. That means that we mix human-based services with digital-based services, artificial intelligence, etc. And we try to optimize the capability to deliver services by that mix. Okay. And so when we try to help companies to make that transition, when they are traditional industrial companies to offer smart product service system, there are different kind of key strategical issues and key challenges for them. For example, challenges on your ecosystem. Why your ecosystem? Because if you have a look at the definition here, when you deliver a smart PSS, well, generally you perhaps don't have internally all the competencies to deliver the full service and product that you want to deliver on the market, because you were oriented on product manufacturing, but you need digital solution, you need perhaps a financing solution also for the client, etc. So you need to work in network. And so the question is also to have the good connection with the ecosystem, with territorial networking situation. And managing all that is also quite important. Another question is the question of platform. If we work on smart PSS, that means that we work on digital services. And when you deliver digital services, you need basic infrastructures to manipulate data, manipulate security, etc. And all that is based on platforms. And the fact that you use platform makes you also dependent of a new key actor, which is a platform provider. So there are different strategical questions around that question of platform-oriented economy and collaboration. Another question is sustainability, because I did not emphasize it a lot, but product service systems are oriented also on transforming the economy toward more sustainability, because by selling the usage, for example, and no more the product, well, we can save a lot of product manufacturing. That means that if we take the example of car sharing, today we have perhaps all of us one personal car, and we let our car in a parking during a large period of time during the day. But if we share the cars, we can increase the level of utilization of the same car by sharing between different utilizators. And so we can reduce certainly the number of cars on our planet, and so have great sustainability impact. So this is a key sustainability strategy, but this is not always the case. That means that managers can use product service systems without really a sustainable focus. They can use it also to increase only business. So how to measure all that and how to try to push product service system towards sustainable solutions. And the last question that we are going to go a bit more inside is the question of management of the design of that a smart product service systems, if we want also to make it sustainable, which design methodology should I follow? When I design such a system, we have seen with Dimitris yesterday that designing only a product is quite complex. We need to manage already the life cycle of the product. But then creating not only the product, but product with packages of new services and with digital services, it's even more complex. So how to design these systems. And what I am going to focus today is also on the question of risk-oriented design. That means that the methodology that I'm going to show puts a focus on the fact that at the time you design such a system, you have at design time, so quite early, to anticipate all the risks, potential risk in putting your system on the market. So let's put now the focus on design and engineering of smart product service system. You should have understood a bit the notion of PSS now. So first, I take the time to underline some challenges for industrial companies. So these companies who want to change their business model towards product service systems. And that change is what we call the servitization process. So when a company was initially, designing, manufacturing, selling products, perhaps the company was selling basic services of maintenance, for example, but only basic things. And it has to be transformed towards a full PSS solution and to sell the usage and no more the product, so to change its economic model. In that process of transformation of an industrial company, it's generally considered as a progressive process. That means that if you have that old product-oriented business, you cannot transform everything in one shot. So generally it takes several years with several, progressive and incremental changes. What do you change when you change that? Well, you change a lot of internal factors in the company. You change the way to innovate because you need to innovate no more only on product, but really to perceive the notion of service and how can you bring new services on all the life cycle of your system. So that means that you need to think in terms of life cycle also. You are going to change the relationship management with your client because until now you were selling one-shot a product. But now you are going to sell the usage. That means that you will keep in relationship with your client during all the usage phase. So you need new system to manage on the long run that relationship with your customers. You change your economic model, as I underlined already. You don't sell one product one shot. You sell periodically a service, so perhaps it's a monthly rent or something like that, so it's fully a drastic change. You need more digital technology, you need to look at sustainability, and you have a lot of internal and organizational changes in terms of culture oriented on services. It's not evident at all for staff oriented on production only and manufacturing, and you need to change quite a lot of processes internally. So it's really what we call a business model change. So that means a change in the way to create value inside the company. Sorry, there are some difficulties here, yeah. So then when we put the focus on designing product service systems, some key questions that we have. First, as I underline, what we have to look is to the notion of value. That means that we need to change a bit our mind, not looking at creating only a product with technical components, etc. We first have to think for the customers in terms of value. And that means that we need to perceive our utilizators, potential utilizators. So we need new ways to capture, the market of usages, the behavior of our clients with the type of system we put on the market. So we need to have new ways to be able to capture all that and to transform that in new design. As you understood, when we design the system, we are not only going to design product, but to design products integrated with services. So that means that the innovation strategy will be transformed also. Which type of service packages will I offer to my customers? How do I integrate really these services in the life cycle of the system? How do I manage all the service demands along all the utilization of the systems and the customer relationship? So all that will change quite a lot the way to manage strategically the innovation domains of the company. And last point, when we create product service systems, not only we create that offers of systems, but at the same time we need to create the way to deliver the whole value to the customer. And as I underlined, that means that generally you do not work alone as a company, but in collaboration with other companies bringing specific competencies. And that means at the time you are creating your system, well, at the same time, you need to create your network. You need to create a way to share value and to share the economic model between different actors, and all that has to be anticipated at design time. So it becomes quite a complex design issue. And so, yes, it's even more open design problems linked to different societal issues. So that means that we create a value system. So 3 key points when we create a value systems are value creation, value delivery, value capture. So value creation, the question is, what is the value proposition that really I put on the market? But not only I put it on the market, I try to align it with value expectations. So how do I capture value expectation, and how I can align my proposition of service packages, quality of the product with these expectations, okay? But this is not only this is not the only thing. How do I deliver value? That means that in the initial definition, we show value channels. So that means that I need to create all the value chain to be able to ensure the quality of what I am delivering. So it is also creation of the value delivery system. And then, well, this value, part of it is economic value, but not only, there is also data value from time to time, because it's a digital system. There is sustainable value, perhaps for some of the stakeholders. So the question is, how do I capture value, and how do I share this value among different stakeholders? Even concerning the economic model, one key question is, at the time I am designing the system, how do I define economic value sharing or economic sharing mechanisms between all the actors of the network? So at design time, we need to solve these questions. Another point in design, already underlined by Dimitris yesterday for products, is the life cycle thinking. That means that when we design these systems, we need to consider all the life cycle of the system and to think step by step, where can I propose to my utilizators, clients, added value services. And then, well, who can deliver that kind of services in the network, etc. So I need to develop in the design team some life cycle thinking and methods. So that means that creating a PSS or smart PSS is something with multiple dimensions of design. There is the dimension of the system I am creating, so the what, the solution, it's not only product, but service and even life cycle integrated product and services, so already quite complex. But you understood that I am designing a value system, so that means that I need to go from a user capture of problems and expectation towards proposal of usages and towards a value, concrete value offer. And then you understood that I need to create also a network and so a value system. So I need to identify collective competencies to mix these competencies in value creation networks, and then for these networks to balance the economic model and value sharing mechanism between the actors. So I need to design on these, all these dimensions. That means that at the time I am designing such a system, well, I am designing a whole business model, in fact. I'm designing how to create value and exchange value between actors. So this is why we need for this, in that transition period, we need to transform also the way to design for the actors. And so the question that we worked on a few years ago was on how to support that design approach, and we developed a full framework, which is SPS2 risk framework. So risk framework because it includes the identification, early identification of risk at design time. And so it's one example of methodology dedicated to smart PSS, and I think you will have some additional example with Judith. It is an overview of that framework. So you can see that there are two design loops. The first one and the second one. So we start all the process here, and there are 5 main steps in the design methodology that you have here. We call them methodological blocks, so A, B, C, D, and E. And so what do we do? Well, we start by capturing the expectation on the design we are working on. So specific steps and methods oriented on design thinking to capture these expectations. And this is quite important to, afterwards, to align all the design we are going to do with this perception of value expectations. Then we start by a step when we prototype the value concept. So we start to build the value proposition, and it's a general design here. And you can see that in this first step, we start to use with blue symbol here, what I will show later, which are conceptual prototypes. So we are going to use the conceptual modeling tools to help that value proposition building. And also we, very early in the design process, start to identify some risks to anticipate them quite early. So general prototype of the value proposition, a second step of more detailed value proposition design, and we are at design time, and we come back here. And so here there is a decision step, just we decide with some verification, is it a mature design, and do we have the potential and the viability to put it to carry on developing it in order to go towards the market. If not, we start again some of the design steps. If yes, we carry on with what we call the validation loop. So it's more a step when the value proposition is stabilized, and we are going to work on how to implement the value network to deliver that value proposition, and how to prototype it and to test it before putting it on the market. So we have two steps of validation, I would say. The first one is oriented on virtuality. So we are going to virtualize the product service system. That means we are going to virtualize the network, the delivery network, in fact, to assess some key aspects like economic sharing mechanism between actors, for example, so we can choose the right economic parameters, and we could assess other things. For example, we have recently developed a new advanced simulator to assess also sustainability at the time we run the product service system. And a last step is an experimental prototype of the PSS, which appears necessary in the methodology. That means that you are going to test really a full solution with key users before going further on the market. All that is necessary because, as you can see, we have risks, a lot of risks, and it's important to have a quite strong methodology to anticipate and assess the impact of these risks. So that notion of risk, so present in all the methodology, you have different type of risks. This is a way to show them. Risk linked to the client, which would be interested or not to change their way of buying a product or using a product and to change their relationship with the provider. So you can have some resistances there. You have some viability risk because your economic model changes a lot. And if you rent a product and no more sell it, you have to assess the risk quite early in the design. Some feasibility risk because, of course, you have new technological issues linked to digitalization of service, to the link between service and product, to the way to manage the life cycle. And so generally, you can have also in the collaboration with your different companies of the network, very strong technological feasibility issues or data issues. And also risk linked to adaptability to the whole ecosystem. Some other resistance factors can appear. And this is why during all the methodology, we have permanent steps to identify risks, to assess them, and then to decide with that vision of the risk, do we carry on with that design or not. A second key notion of the methodology is that we use prototypes. And in fact, as perhaps you have seen, we use different type of prototypes. So prototyping is that means that you are anticipating your system before having a real system. And we have these different type of prototypes. Finally, what I am going to show, conceptual prototypes, that means that only we have that use of conceptual modeling tools to define what we call the value proposition, to define what we call the product service system, or even the market offer that we put on the market. So all that makes possible to make explicit really the design we are building, and to make that makes possible to interact with all the actors of the design team on understanding the point of view and integrating the point of view. So this is the first type of prototypes, only conceptual models. A second type of prototypes, or what I call the simulation. So when we are going to have a dynamic simulator of the product service system delivery network to assess the economic model or some performance factors. And the last prototype is the experimental prototype, where really with key users you test really advanced solution. So we could call all these support for the design prototypes. You have here a full vision of our methodology, so a synthetic vision. It has been published with a lot of detail at each step of the methodology. So you find again the 5 methodological blocks that we saw before. And behind each of these blocks, you have, of course, sub-steps defining very precisely how to design how to proceed in the design process. And the point that we are going to look at is the fact that in some of the key steps of design, we are going to use conceptual modeling. And this is what I am going to show later. So if you want more information on the methodology, of course, it's available as a PhD thesis, so you can get access to it. And through some papers, of course. So now that you understood that we have a design methodology, let's have a look at what I call conceptual modeling tool. We developed a special tool called the modeler, which is a modeling language dedicated to smart PSS design. Here again, you can get access to the definition of the language. So it is part of what I call conceptual prototypes. So what is it? Well, it is that kind of environment that you know today with specific type of models here. We have 10 types of models, which is each model providing a modeling language. What is it used for? Well, it is used for to support the process design, so to be able to help the application of the methodology that I defined. So you have specific steps using these modeling languages. So the tool itself is structured the same way as the methodology, so helping the designers to integrate the methodology. Of course, it's capture a lot of information and knowledge on the design. So it's a question of knowledge sharing among all the participants to the design team. And it makes possible to facilitate the qualitative and also quantitative analysis of key risks during the design process. And we capture in this kind of models also key element of information on the economic models. And these elements of information, we will reuse them later for a second tool that is a simulator of PSS network. So basically, it's a computer environment to create a key representation of the product service system and the associated business model. And yes, to capture a large amount of technical information on this business model. We are going to have a look at the model. However, first, how did we create that model? So it's a meta-modeling process, and I imagine that you have already seen some key insight on how to create a new meta-model. So you have here the key steps that we followed methodologically to create that modeling languages. From capturing expectations on case study of designing PSS, specifying a conceptual meta model, validating the conceptual meta model with a smart PSS expert, then developing the language, the tool, and with a technical validation by industrial expert of the tools, and then verifying the applicability by full case studies. And so at the end of all the meta modeling procedure, we generate different outputs. One output is the modeling language. A second output is the modeling toolkit to use the language. And the third output are the application case studies also, which can be quite useful. And one particularity is to develop that conceptual meta model. We did not did it in one step, but with an iterative process. That means that we use several case studies. We started from a basic existing language for PSS, and then we use different case studies of PSS to try to develop that conceptual meta model, in order to be able to cover different contexts of design. And this is what I show here, that the final meta model we provided was based on using a first case study and developing a meta model from that first case study. And at any time that we generate a new meta model, because we have been looking and studying a case study, industrial case study, well, we start from that new meta model with evolution patterns coming from the case studies, integrating these new patterns in a new meta model, providing consistency checking to go further in the process. So it was an iterative process to develop the meta model using different case studies of industrial design of PSS. And to show a bit our meta model, yes, it's a bit show like that. We have at the end 10 models which are useful to support the process design. And we can present them like that. Two first models are what I call contextual views. That means that they do not contain information on the PSS itself, but more on the context of the PSS. Yesterday, with one of the professors from Spain, you saw how to align software development with organizational issues and strategical factors. That means that before developing a software, you need to capture some key objective of the development of the software. Here it's a bit like that. The contextual view will capture key element of the ecosystem in which you want to develop your new PSS offer, key element of description of the organizations you are going to collaborate with. So these are contextual views before defining the value proposition you are going to develop. Structural views are the 4 views which are really focusing structurally on defining the key content of the PSS. So the product-oriented content, service-oriented contents, all the activities necessary to deliver services and products, and also what we call the offer. That means the configuration of potential economic models to put the system, the solution on the market. And then we have the behavioral views. That means more dynamic elements of information which will help later to assess the PSS and to assess delivery network of the PSS. So we have some key quantitative information on the demand for the different offers that we can put on the market, on the performance indicators on which we would like to assess the solution, on the definition of the value network and value delivery network with the scenario, and more largely the value network, which is a complementary vision. So we have 10 models, and if we have a very short look, each of these contextual views, so gathers, yes, modeling objects which are necessary for our view. So we don't have time to go in detail. For example, here we have conceptually the organization view and the ecosystem view. The organization view, if we look at it in the operational modeling language, so this is the same concept here of the organizational view, but with the graphical representation of the view. So you will find what I called organizational actors here. So this is what we define in the conceptual model here, with different type of organizational actors, which can be resources, operators, or etc. And so we find here some of these components, resources, actors, and they are linked to activities that they can provide, and they are also linked to risks. That means that in that organizational view, I start to define which actors will be necessary to be connected in the network of delivery for the PSS. And I define for each of these actors the key capabilities that they can provide in the network. And at the same time, I try to identify with these actors key element of risk evaluation. So this is one of the views. You have here the structural views. So the structural views, as mentioned, covers product, service, activity, and offer view. Yes, for example, we have the offer view, which is here. When we have key element of information on, so what I call the offer, which is linked to a contract. So way to define economic relationship with your clients. And we have the three types of contract that we saw before: product-oriented contract, use-oriented contract, and result-oriented contract. And the offer is also linked to service packages and to providers. So if we look at the operational language, you will find an offer here linked to a type of contract. The type of contract is linked to some categories of customers. And we, of course, deliver the offer with a provider. And then the offer is linked to service packages, which are defined here, and also key product reference. So behind all these symbols, of course, we have technical information. For example, we have technical information to define the contract in that case. Technical information here defining the demand, potential demand of that type of clients. And all that information is further used later in the design process. And then we have dynamic views. So performance, scenario, demand, value network. So, well, the performance view is going just to define some kind of indicators that I will need to assess my system. The scenario view is very important for us. You can see that there is the notion of role here as assigned to an organizational actors. So with the scenario view, what we are going to modelize is the delivery network, so the value network necessary to deliver the PSS on the market. So that value network is based on the fact that we have different roles necessary to provide service activities, to provide the system, etc. And with this key concept, we are able to modelize all the value network. But there is another the delivery network that I call the scenario. There is another notion, which is the larger value network. That means not only the actors who really are in the economic model and deliver the system, but there are other stakeholders around the systems. And I developed a full vision of all the stakeholders. And this is here the value network view that we modelize. And as you can see, what we show are here the type of values which are exchanged between the actors. And we consider not only economic value, but the fact that there is some transfers of value between the actors linked to, of course, financial transaction, but also environmental value, social value, relational value, and functional values. So different flows of value between all these actors. So at the center in that example, you have a key provider, but you can see a large amount of actors, including for some financial issue, insurance suppliers or governance agency which provides some funding helps for that kind of heating systems, etc. in the example. So this is not the delivery network, this is a larger value system in which our system functions. And it's quite important at design time to be aware of all the links between these actors. So here is the full meta model. However, we are quite close for the end. So I mentioned before reference of a paper to go deeper if you want to understand a bit more all the model. What I would like just to underline quite quickly at the to finish my speech is the fact that not only we have that conceptual modeling tools to support the design of smart PSS, but we have developed a second tool, which is a simulator, notably to establish the economic model of the PSS. So that simulator, so we saw before that type of prototype, conceptual prototypes. And here the simulator provides a second type of prototyping, which is a virtualization of the value network to deliver the PSS. And so the question with this simulation is to be able to assess the behavior of the market with regard to my offer on the market. So it's a economic-oriented simulation. I am going to simulate all the activities necessary to put the offer on the market. And I can simulate alternative economic models. That means several offers that I could put on the market, but I need to decide what is an optimal scenario, the optimal offer for the market. And it is a multi-actor analysis. That means that I'm going to assess that economic model from the point of view of different actors in the delivery network. One of the key difficulties that we have is that it is a strong effort to develop this type of simulators at any time you want to design a new system. Because the simulator itself, if you want to have it quite reliable with pertinent indicators of performances, the simulator itself has to be aligned with your case study. So that means that you need to adapt your simulator for any industrial case of design. So to underline that, and that will be the end of my presentation, I just want to underline that we have integrated the conceptual modeling tool that I presented before together with the simulator. How did we try to integrate them? Well, because we have two tools, but the two tools are based on the same meta model, the same concepts behind. of activities, actors, economic parameters. So all the information that we capture in that conceptual modeling tools at design time, for example, you have seen the contract with different elements of information on the contract. Well, all this information, we transform them to the development of the simulation platform. For example, I mentioned the scenario view. In the scenario view, we define the delivery network, so all the roles necessary with organizational actors to do that. And so all these scenarios defined here are transformed in parameterization of the simulation platform. So the question is to have a rapid customization of the simulator based on these two. But I don't have time to present here. So as, excuse me, can I go back? Just to close up my last slide. Oh, a lot of slides. A lot of slides. Here it is. 9 o'clock is 9 o'clock. So, yes, in the slide you have the references to go deeper in what I could not explain today. Perhaps, do you have, yes? Okay, so, well, the methodology itself is helping you because in the design process, we will integrate that identification at certain stage of all the data necessary and where does the data comes from. And so at given point of time, we take these key questions and we make a risk assessment on data privacy and what solution to manage the risk. So the methodology will help you in the fact that it brings the designers to have this key question that you ask. However, the solution that it is integrated today is only to have that risk protocol to identify more clearly which risk link to data, to have some key assessment of the gravity of the risk, etc. So it's quite a traditional risk framework to assess that. So nothing very specific, I would say, to the digital technological issues. Yeah. So it's more methodology that helps than a technological solution.
Professor Boucher will be around. Any other questions, please, later.
Okay, thank you very much.
I like to show you got your minute, okay?
Thank you.